Okay, so this gravitational force, it has range of infinite, we can say, because it is seen everywhere. Even though it is small, it is very much weak force, but it has a longer range. Then comes our second force, second fundamental force. That's also a square law following, which is electromagnetic force. This is second fundamental force, electromagnetic force. And this electromagnetic force, you have to remember about this, it only exists only in case the particles between which it is existing are charged in nature. It exists only between charged particles. So if the particles are charged, if the masses are charged, if the bodies, if the systems are charged, then only this very force is existing. For example, this is a particle A, or a system A, this is another system B. If this has charge 0, this has charge 0, no attraction or repulsion, whatever it is, no electromagnetic force. If no charge means neutral. We have to have at least and at most both of them charged, because if one of either of them is neutral, there is no effect, there is no electromagnetic force existing. So these two must be with some charge. Say for example, this charge is represented by Q. This is Q1 charge, this is Q2 charge. This very particle has Q1 charge, this very particle or system has Q2 charge. And the distance between the centers of these systems, again, take it as R. So this is also a central force in nature, central force. And the force is given by Coulomb's law. Coulomb's law, which states that force between the two charged particle, Q1 and Q2, the two charged particle, is equal to, similar in case of the gravity, there were two masses, here are two charged, Q1 multiplied by Q2 divided by R square. So that means this is also a square law. Inverse square law, because it is inversely proportional to the square of distance between the two particles. And there is a constant, like in case of gravitational force, you have seen the constant G, and here the constant is 1 divided by 4 pi epsilon 0 or epsilon naught. This epsilon is called as the electric constant, you can say, or the permittivity, for short permittivity, or vacuum permittivity. You will come across these things again and again in the upcoming classes, so don't worry about the hoo-ha of these names or something else. So be cool. So force law, which is Coulomb's law, is F is equal to 1 upon 4 pi epsilon naught Q1 Q2 by R squared between two charged particles having the distance R between them. Now comes the portion, this whether it is positive or negative sign to put on here. So in case of here we don't put any sign, so no sign. Why? Because maybe the two particles Q1 and Q2, maybe this is positive, and we know like charges repel, then there must be repulsion. If this is positive, this is negative, then there is attraction. So it depends upon the charge what kind of charge it. If it is negative and it is negative, then again repulsion. So if charges are of same nature, then there is a repulsive force existing between them, and that is repulsive Coulomb's force. And we know repulsion, with the force which is repulsive in nature, it is positive. And in case it is attractive, that is the Q1 and Q2 are of opposite nature. One is positive and another is negative. That means there will be an attractive force existing between them, the electromagnetic force of attraction. So in that regard, like the gravitation, it will come negative. But that depends upon the charges. So for best or for better, it is not written down here, neither plus sign nor minus sign. So it depends upon what kind of force is existing between the two particles. And the value of about this permittivity, value of permittivity is equal to, this is called as electric constant also. Its value is equal to 8.854 into 10 to the power minus 12 Coulomb square per Newton meter square. In a similar case, in a similar fashion, you can calculate the units of epsilon as previously I calculated from gravitational force. You can calculate from the Coulomb force. Just put it down, like just cross multiplying the things and rearranging the stuff, you will get the, you have only to note down that in case of gravitational force there was a mass, but here it is charge, and the charge have the units of Coulomb, which is represented by C. Only thing you have to do. So that means C into C means C square, divided by R square means meter square. This will be multiplied to this, okay, Newton meter square, and Coulomb square will be like this, and this E naught or E0 will be replaced by F here. So F has units of Newton, it will be in the denominator. Okay, so you have got an idea about these very things. And I have also already told you that this electromagnetic force, almost all the forces which are observed in our daily life, in our day-to-day life or daily life, have the fundamental force existing as electromagnetic force. The fundamental force behind all of those forces, like muscular force, viscous force, the viscosity inside the fluids, the buoyant force inside the fluids or liquids, and the spring force which I discussed earlier, the contact force, the friction force which is existing between the two systems when they slide onto each other. So all of these forces have fundamental force as this electromagnetic force. So these were the two forces which are observed in our day-to-day life. Gravity is also observed like this. Electromagnetic force is also observed in our day-to-day life, like I said, in the muscular forces, spring forces, frictional forces, or other stuff like that. But there are other two forces which are existing inside the universe, which are existing inside the nature, and those two forces are called as the nuclear forces. Those are called as the nuclear forces. Nuclear forces.